Hello everyone and welcome to the tutorial videos for the Virtual Robot Racing League. In this video I'm going to cover setting up your development environment for robot AI development. Now before we get started I want to mention that it's recommended you already have a basic understanding of programming in C#, linear algebra in 3D, and physics before starting. If you don't, then for best results you might want to read up on those subjects online first. You don't have to be an expert, but when you're trying to control a robot in a physically simulated environment, it helps. Okay, let's get started. The first thing you'll want to do is install Visual Studio if you haven't already. I recommend version 2017 for this, but any version newer than that should work fine too. If you don't have Visual Studio installed, you can go to our downloads page, and we've got a link to Microsoft's website where you can download the official version. The next thing you need to do is download our API and testbed. The API is just a small zip file, but the testbed is a larger 3D application. Go ahead and start those downloads now. And if Chrome gives you trouble, go ahead and tell it it's okay. Okay, let's switch over to Visual Studio. The first thing we need to do is create a new project. This should be a class library for .NET Standard. So let's go ahead and select that. And then we'll go ahead and name it My Robot AI. You can choose if you want a separate directory for solution, doesn't really matter here, that's up to personal preference, whatever you want to do. Once you got everything selected and good to go here, we'll hit OK. Visual Studio will create our solution for us. First thing we'll do is get rid of this auto-generated class we don't need. And then we'll right-click on the project node, choose Properties, and we want to make sure this is all right. Now you can update the assembly name and default namespace as you want. That is going to become important in a minute when we set up the startup class, but for now you can pretty much do whatever you want filling those out. The important part here are these two. We want to make sure the target framework is set to .NET Standard 2.0, and we want to make sure the output type is set to class library. This looks good, so we can go ahead and close that now. Okay, so let's go ahead and import the API file that we downloaded. So from Chrome, the VRRL API.zip. We'll go ahead and open that up, and we're going to put it into our project here. We'll just go ahead and put it in the project group for now. Should just be one DLL file. And back in Visual Studio, we're going to right-click on Dependencies under the project node. Add reference, browse, and we'll go ahead and select the DLL that we just extracted. Okay. If we unfold dependencies, we should see, there we go, perfect. So now we've got the reference set up properly. Now, our project needs two classes at minimum to work in the test bed. The first is the main controller for the robot, so let's go ahead and create that. And we'll go ahead and call that My Robot AI Controller. Okay, goes into our default namespace here. We'll make the class public. And then the key here is that we need to derive this from the robot controller abstract class. Now, we don't have a reference to that because we're not using the correct namespace, so we'll just do quick actions, and that will pull in the correct namespace for us. Now we've got a red line under the class name because we're not deriving the abstract methods. So let's go ahead and implement the abstract class, and now that the compiler is much happier. Next, we'll need the startup class. Now, this is what links everything up, so it needs to be named just startup. Let's go ahead and add class startup. Now, this is a little bit tricky. So, normally you can do whatever you want with namespaces, but for this one specifically, the namespace that the startup class is in must be the same as your assembly name. So, back in the project properties, you can set the assembly name and default namespace differently, and if you do, then it's going to do the namespace here different. But if so, just set that back to the assembly name because it needs to match your resulting DLL name for the test bed defined in the startup class properly. It just looks for DLL name as a namespace and then startup. So as long as all this is named properly, everything will hook up properly. It's only this class where it matters. And we want to derive that from the iStartup interface. Again, we're going to go ahead and let Visual Studio bring in using for us. And the iStartup interface only has one method that needs to be implemented: get controller type. We've already defined our controller type, so we can just do return type of my robot AI controller. And that's the whole startup class. That's all you need to hook up everything. The rest will be done by the testbed application. Okay, at this point, your project should have everything it needs at a basic level. So if we go ahead and build it, it should build. And that succeeded. And if we go to the output directory, we should have our DLL. Perfect. So now we can go ahead and load that into the testbed application, but it's just going to throw a couple not implemented exceptions. So it's up to you to start building out the behavior into your controller class. So just before we end this video, let's go ahead and take a look at the 3 auto-scaffolded functions here. The initialize robot function is called after the connection between the robot and your controller is established. Once this function is called, it's safe to access your controller's robot reference. So from any of the local functions, you can access the robot reference, and that's going to be a type of Robot Explorer, I believe is the type name. And we can go to the Developer Center. iRobot Explorer is the type. So here's the documentation for that, and you can see all the various controls, properties, functions you can call on that to actually control your robot. Once the initialize robot function is called, that's when you can start accessing this reference and start calling those functions and such. The second one, process signal from Arena, is called whenever the Arena sends your robot a signal. These signals are based on an enum type, so you can check that out. There's not very many of them right now, but that may increase in the future as this gets more complicated. But right now, basically, the Arena just tells you when to turn on, when to turn off, and when to start mixing. Make sure you check the rules on the website so that you don't start moving your robot before it is allowed. That is a fault. And finally, you have the update robot function, which is basically just your standard tick function. By default, it's called 50 times a second. However, your robot will have a time sensor to tell you how many times the tick function is called and also how quickly time is flowing. So normally that's all going to be set to the default, but you never know. If you join an impossible challenge, it could be very, very different. Anyway, this is the basics on how to set up your development environment. You should be all set to go now. I hope you enjoyed the video. Thanks for watching. We've got more videos if you need a little bit more help, or you can check out the next video, which will cover how to test out your robot. Thanks for watching.